A very good evening again to the you. Now, as you all know that we'll start with today's part, that is all about based on electrical dipole and its types. Means we have to calculate electrical field due to electrical dipoles. Now the dipoles are placed at the two conditions, at the two stages. The first one is what? At an axial point, means electrical dipoles are placed on an axis, straight. And the second part is electrical dipole, or we can say the electrical field that we calculate for electrical dipole that will be placed at an equatorial point, just perpendicular bisector at. Means we can say first time we calculate electrical field to electrical dipole for an x-axis point, and the second part is calculated for y-axis point. So we'll begin with the first derivation in which we calculate how we will calculate electrical field due to the dipoles. Dipole means what are dipoles? What are dipoles? Dipole means when there are two charges of equal and opposite polarity placed at small distance apart, then it is defined as the product of magnitude of one of the charge, that is q, and the small separation between them, that is 2a or say d or m. So we know it very well. The dipole formula is P equals to q into 2a, where P is a vector quantity said to quote a dipole moment, electrical dipole moment. Q is the one of the charge, and 2a is the displacement vector, or we can say the distance between the two charges placed some distance apart, that is 2a. Now based on this, we will draw the diagram again and we will find the electrical field due to these charges. Means as you all know, plus charge produces a kind of electrical field around it, and minus charge also produces an electrical field around it. So now, if there are two charges placed some distance apart, in total, the net electrical field will be what? And in which direction? And of which magnitude? So, from this electrical field due to an electrical dipole at axial point, we will derive it. So, we will begin with the part. How we will calculate this part? Now, let's start with that. First, we will draw the electrical dipole. We will draw the electrical dipole, or we can say the electrical dipole moment we will calculate, and then we will find the electrical field due to this. Now start with that. First thing we will draw what is written here at axial point. What is axial point? This is the axial point. Let's suppose here this will be the axial point. This is the axial point. Axial means at this x-axis, we will say to what an x-axis, or we can say on the side end. On this is called a side end. We will find the electrical field at side end, either this end or this end. Now we know it very well. What we know? We know it very well that this is what minus q charge. Let's suppose this is what minus q. This is what minus q charge. Make it like this. As you all know, the direction of electrical field always from minus q to plus q. Always from minus q to plus q. Now we will assume it like this. This is the charge, plus q is placed here, and this is the charge, minus q is placed here. Let's suppose this point A. This is point B. The distance between minus q and plus q is always 2a. Minus q and plus q is what? Always, is write it like this, 2a. Now as you all know that this is what, let's suppose this is what a middle point. This is what a midpoint. It is supposed to be what kind of midpoint. Let's suppose it is what? It is O. Let's suppose this is what? Now, If it is midpoint, then the distance from A to O will be A. The distance from O to B will be very easy. Now, as we all know, always we know it very well. If there is single charge is placed, let's suppose plus 2 charges placed, an electrical field is formed around it. An electrical field is formed around it at some distance. Not here, at some distance. In the same way, we'll say here, the electrical field. Now we need not to be calculate the electrical field to individual. We have to calculate the electrical field to both these charges. And the combined these charges are supposed to be called an electrical dipole. Now how? Due to B, let us suppose we have to calculate electrical field due to A or due to B at some distance from B. Let's suppose the distance is what? Here. Means we have to calculate electrical field at point B. Means we have to calculate electrical field due to point B, due to point A, where the charges are placed at point B, which is some distance apart from where? From where? Let's suppose the distance we always take the distance from the center point. Let's suppose r distance apart. Means we have to calculate electrical field due to these two charges for electrical dipole at point P at some distance r. Now, how we calculate electrical field? Let's check the direction. Let's check the direction. At point P, let's suppose electrical field due to charge placed at B on P, what it will be? Let's suppose we say due to B, we have to calculate B. Now B is what? Positive charge. And there is some charge placed, always will be considered to be a positive, a kind of positive charge. If there is no charge placed, it is considered to be a less charge. Means it is a positive charge. This is positive charge, let's suppose. This is positive charge, always positive. Always positive. Means there is a repulsion takes place. In which direction? In the direction what? Away from the point P. And assume it to be what? Some value. Means from B. Means you have to calculate electrical field at point B. Now we assume to what? Not E, it what? E. And in the same way, we have to calculate electrical field at point P due to A. Now, one more thing. What will be the direction of this part? The direction will be here. Repulsion. In the same way, the charge takes place at point A minus Q. And this is what? Let's suppose plus. Now, the direction will be what? Towards A. Why? Because it is attracting the charge. It's what? Attracting the charge. Means the direction will be what? Here. Direction will be towards A. So due to, now what we write here? We write electrical field